All right, so here's what we're doing is we are doing the equations like this, but we're using directly going to it. We're not doing the equality and then plugging in the values. We're actually going to use absolute value of ax plus b less than a k. And then so we're going to go from negative k to positive k. And then we have the tripartite. Or when we have greater than k, we're going to have the or. We're going to have it less than a negative k or greater than a k. And again, we can use the equalities along with it if we have greater than or equal to or less than or equal to as well. All right, so let's do one where we just have strictly greater than. So it's going to look like this one. It's going to be less than a negative k or greater than a positive k. So drop our absolute value and we have that. And they're going to work it here, with the equalities. And so those are going to be your two values. And so x is going to be less than this one or greater than this one. Now, that would give us the interval notation between negative infinity to negative 14 thirds, union 6 to positive infinity. Okay. Now, the other way you could have done it is, again, plugged in our values here and solved two different pieces and worked our way down that way. And so, that's kind of more of the typical thing you would have done is done it with that. And so you would have probably gone through and said, okay, well, you have 3x minus 2 over 4. And then again, you're just doing less than the negative k. So you're going to do less than a negative 4 and then or and 3x minus 2 over 4 greater than a positive 4. Now multiply. So 3x minus 2 less than negative 16. Add 2 and 3x is less than negative oops, can't write that. 14. And okay, so and then divide by 3, x is less than negative 14 thirds. Here, multiply by 4, so we have 3x minus 2 greater than 16. Add 2. Did I add 2? Yeah, okay. Oh, that's make never. Oh, okay, I'm seeing what I'm doing wrong. And so 3x is greater than 18, x is greater than 6. And so, we have from negative infinity to negative 14 thirds union 6 to infinity. And so hopefully that's what we have here. So this is more along the lines of how it would be worked using the piece over here. The way they showed it was using kind of the old way where you set it equal to 4 or negative 4, and then you have to plug in the values in the appropriate places. So then you have to think about what goes where. But if you just do it with based on the formula, then you don't have to worry about any of that. All right, so here we have an engineer designing a circular cover for a container. The diameter of the cover is to be 4.75 inches and must be accurate within zero point zero 0.05 inches. Write an absolute value inequality that gives acceptable values for D. All right, so what basically we have is the diameter has to satisfy this range. Okay, has to be, if we add zero point zero 0.05, that's going to be 4.8. And if we subtract that, it's going to be 4.7. So it's going to be between 4.7 and 4.8 is for our diameter. Hence, we have this. And so what we could have done is we could have done the following. We could have said, okay, well, the diameter has to be within 0.05. So we're going to go from negative 0.05 to a positive 0.05. And our diameter is equal to what? Well, d minus 4.75, less than or equal to, greater than or equal to, and then just solved it down. And then we would have got our 4.7 less than or equal to d, less than or equal to 4.8. And we could have got that here. We looked at it and just said, okay, well, it's going to be either plus or minus this. So plus that and minus that. We got those two things. And so that was our region. And so what does our absolute value look like? Well, because it's the tripartite, we know it has to be the less than or equal to, and our diameter is, minus 4.75 is going to be less than or equal to that. So that's going to be our absolute value. So it's one of those things, we can get it directly, like this, but they said they want the absolute value inequality. And so then we just kind of had to work our way through it. So we knew that that was kind of our piece that we had to do. This represented, now if we go back over here, this represented this one because it was that. And so we know the absolute value of the d minus 0.75 is less than our 0.05. And that's what we have here. Okay. So sometimes you have to do equation different ways to figure out what you have, but that's what it's asking for in this case. All right, now we're supposed to solve if possible. Well, most things are possible unless we have less than zero or less than, yeah, you're equals zero, less than zero. So first things first, I'm going to subtract 2. Now it says the absolute value of 4 minus 3x, and that's going to be greater than or equal to a negative 1. Okay, well, make sure we're doing that. Since it can't be negative, that's greater than negative 1 for every value of x. So no matter what we do, it's going to work. And so that's kind of one of those key things. Anything we plug in here is going to be greater than negative 1. So that's kind of a cool application of this one is with absolute values, you're going to get a positive. So this saying it's going to be greater than a negative 1, and that's going to happen at every value of x. Now, what about this one? 6x minus 5 is less than 0. Okay. Since we know absolute value is always greater than or equal to 0, nothing we plug in here is actually going to work. Now, if this had been equal to instead of just less than, then that's a different story. But because it says strictly less than, it's never going to happen. So there's going to be no solutions. So that's one of those that you have to pay attention to. If this had the equal part, then that's going to be one thing. But since it's strictly less than, absolute values are always positive, and so therefore it's not going to work, and so there's no solution. All right, so that's all I have with this. Hopefully that helped.